In a shuttle launch, weight is crucial and very expensive. It costs NASA a whopping $10,000 a kilo to defy gravity. In fact, around $80 million has been spent ferrying 6 tonnes of water up to the International Space Station. That's $40,000 a gallon, around $10,000 a litre. If NASA could recycle its water up in space, it would not only save millions, it would also help mankind get to Mars. A mission to Mars and back would take more than 2 years, way too long to take all that water with them. A US company here in Reno, Nevada has a system that can recycle an astronaut's waste fluids. Sweat, tears, exhaled breath, even urine. And more importantly, the same system can be used to give millions of people in developing countries crystal clear water. Now, you know on Beyond Tomorrow, we like to put the technology through its paces. Well, my producers say I've got to put this one to the ultimate test. Drink my own urine. The things I do for this program. Let's just freeze my personal humiliation right there and take a close-up look at this whiz-bang technology, with the emphasis on the whiz.
This is a prototype, but there is a cartridge like this on every space shuttle that has ever flown.
More than 20 years ago, chemical engineer Jerry Colombo developed a way to make sure astronauts had safe drinking water. This anti-contamination valve keeps the shuttle's water supply clean by using iodine to kill bacteria and other bugs.
We put iodine on a plastic bead, if you will, and then the bead releases it into the water on demand.
Jerry's big breakthrough was developing special resin beads impregnated with iodine that release the chemical in a slow and predictable way. There's enough iodine here, just 100 cc's, for a lengthy shuttle mission.
That'll handle 30 days worth of water for a crew of 6.
I mean, it seems remarkably simple.
It is. That's the best part. Best ideas are very, very simple.
Jerry's simple but clever idea is a key part of this new water recycling unit, designed with astronauts in mind. It uses the slow-release iodine filter, along with a whole raft of other filters, to clean up even the nastiest bodily fluids. This is how the system works. The dirty water comes in through this big pipe here and then goes through a whole series of filters. First port of call is this one. And there's a particle filter in there. Basically inside here is this thing, and it's a very fine plastic mesh that filters out the dirt and the other particulate matter. In fact, it can filter out particles down to 1 micron, 1/1,000,000th of a metre, so pretty fine filter. Once the particulate matter is taken out, the water passes through the second filter, which is a carbon filter. So inside there is something that looks like that. Now, carbon absorbs chemicals, so in this process, the herbicides and the pesticides are taken out of the water. Then, the next stage is around here, this little one down here, which is where the iodine is added to the water. Now, the iodine kills living creatures, so it kills off the viruses and the bacteria, giving you some quite clean water, but it's now full of iodine. So there's a couple of filters here to take out the iodine, because that only tastes bad. For some people, it also is bad for them. They're allergic to it. And there's one final step in the process. Back here, now there are some bugs that this whole system just won't kill. Things like Giardia, Cryptosporidium, that have to be killed in other ways. What they do is actually just filter them out. So inside here is this incredibly fine filter, down to 1/2 a micron. So basically the bugs just can't get through here. And out of the pipe in the end is beautiful, clean drinking water. There are no meters or valves. It's simple. Ideal for up in space or down here on Earth.
The advantage of that is in space you want things as simple as they can, and as an extension in third world countries you want it as simple as possible.
A staggering 1 billion people, 1 in 6 of the world's population, don't have access to clean drinking water. Many millions of these, a lot of them children, die every year from drinking unsafe water. To prove how the filtration system would work in developing countries, the company building the water purifiers has organised a field test. The water here near Reno is dirty, polluted, and looks totally undrinkable. Aha, this is the setup.
Yeah, here it is. This is our discovery system. This produces about 15 litres per minute. So that would be about 6,000.
15 litres a minute?
Yeah,
That's high flow rate.
22,000 litres a day you could get out of this one system.
Ken Carney's company, Water Security, has also built a compact portable unit that pumps out 2 litres a minute.
So
Okay.
where this would be used is if we had 10, 20 people in a very small village, we could again use this the same way we're using that, only we just pump it by hand.
So there's no solar panel required, no electricity required, it's just a simple...
Nothing at all, and it is portable. You can carry it with you. So this is going to be used in all kinds of disaster relief situations, small villages, missions out in the field.
It does taste amazingly good. A simple idea that could be saving lives here on Earth and allowing mankind to push back the boundaries of space exploration.